Good morning, everyone.
Good morning, sir.
Guys, have you done the revision for the logistic one?
Yes, sir.
Okay, it will be great. Once again, I'm just sharing a screen. Just 2 minutes. System get hanged. Is this cross check till where you have written?
In line number 35,
This line number 76 is the last one for you. Okay. It's done till here.
Yes, sir.
Shall I explain? On screen. Point number 1. It's going to use logistic regression. When we have yes or no, or we can say it is used for classification. Okay. Type of data required is yes or no. So first, let me import data. Guys, I have taken data set of nothing but insurance data, or I can, sorry, a diabetes data I have taken, in which the patient have a diabetes or they do not have a diabetes. That is the data we have. In outcome 1 means patient have diabetes. Outcome 0 means the patient does not have diabetes. Okay. And we have taken a data of 768 number of customers. And these are the independent variables. Okay. First, we check the structure of data, guys. So here we have coming as an outcome. If you see the outcome variable coming as integer. As per the rule, Y variable outcome has to be category. So S dot factor. S means convert. Factor means converting into category format. Data set name, full data. Column name, outcome. Assigning in same data. Now if you cross check, prior outcome was integer. Now it's become factor with 2 levels. Clear? Next. We will verify whether it's a have missing values or not. So S apply full data. Okay. Will behave like X. This means check. Checking name for each and every column. If present, do a sum. Guys, do we have missing data anywhere? Cross check.
No.
Okay. So we do not have any missing data present over here. Okay. We make a box plot. Here, if you can see, we have outliers on many ways. Okay. So I believe you know how to treat outliers. Okay. By using venturizing or using capping flooring. Okay. Next, guys, we move for data partition. I'll explain this again. It's a very important part. I did set.seed. Set.seed is similar to your, let's say,
Random state.
Okay. Then I say do a partition using a package called Caret. So Caret is a package used for partition. Within Caret, we have a function called create data partition. Based on outcome number of rows, random rows, 70% data have to be taken. List false means do not break data column wise. Need to break data row wise. Whatever row come in sample on this one, same sample will go for name. Remaining data will go for list. As you can see in training, we have 538. In testing, we have taken approximate as 230. Okay. Next, guys, moving to a model. The LM. Last time we have done LM model. LM stands for linear model. GLM stand for generalized linear model. Okay, generalized means it takes any type of data. So X can be category, X can be number, it's okay with that. Next we say outcome as my Y variable depends follows dot. Means your Y variable depends on all the columns. Family binomial is meant to use binomial distribution. Anyone? I'll repeat my question. When to use binomial distribution? You have, I'm teaching the stats. Yogesh, Shubham. Guys, do Google. Okay. Anyone else? When we have success and failure. So binomial distribution is used when we have two possibilities, success or failure. Have diabetes or don't have diabetes. Okay. Binomial always give answer in terms of probability. Okay. So whenever we have two levels in Y, we use binomial. Data taken from training. We check the summary of this. Now in the summary, guys, here which method we use to check the accuracy of model, guys? Guys, we have done approximate 20 times, 30 times. In classification, which method we
Confusion
use?
matrix.
Confusion matrix.
By using
Perfect. So we use confusion matrix to check the accuracy of model. Now on this screen, which is a summary, this summary report never give any accuracy. This summary report only give you beta naught, beta 1, and so on. What is the equation for logistic, guys? No. Y is equal to beta naught? No. Anyone? Open your theory book.
1/1 plus e raised to minus beta naught plus beta 1 plus epsilon.
Okay, it's 1 upon plus e raised to. Then same equation, your beta naught, beta 1. Okay. Guys, I informed you to revise and come. What happened? Face any difficulties for revision? Guys, do you want me to teach that logistic one again?
No, sir.
Okay, thank you. Now here you can see intercept is called as beta naught. This is called as beta 1, beta 2, beta 3. So now, guys, in question comes which variable is highly influencing. Which variable have p-value less than alpha? And whichever variable have p-value more than alpha, that variable has to be removed. And this is more than alpha. More than alpha. So this two variable has to be removed from the model. So to automate remove, in R we have a function called steps. Say, see, query from here till here is same. Same as above. Only I just add a step. Step means do one by one cross check whether variable is important or not. The method is both. You can use forward, you can use backward, or you can use both method. Now, can I say all the variable have p-value less than alpha? Clear guys? Any question? Let me write guys. Okay, how it works. It has some mechanism. Okay, just give me a second. चेयर पास कर दूंगा. Okay. Guys, can you see the screen? First, I'm teaching you forward. Okay. Then we'll come to okay, x1, x2, x3. ये clear हो गया. Let's say x4 also. You run the model. Correct? तो यहाँ पे आपको मिलेगा बीटा नॉट, यहाँ पे x1, x2, x3, x4 और यहाँ पे आपको मिलेगी उसकी p वैल्यू. करेक्ट? Let's say I'm just setting a random numbers. Okay. Which have p value less than alpha? Alpha value is how much, guys? This number is less than alpha. Number is less than alpha. But this we have a method called variable selection method. Okay. Automatically we select the variable. Okay. Variable selection method, in which we have three methods: forward, backward, both. We will understand what is forward first. In the forward, step number 1, it takes only intercept. कौन सी वैल्यू होगी? सिर्फ बीटा नॉट की वैल्यू. Okay, here will be a coefficient. Let's say number coming 2.36. ये clear हो गया. Now what happened? He will, whichever variable has the lowest p value, that variable will enter. ये clear हो गया. Second, x2. Any variable has less than p value. Now remains as per the screen. No. So this will stop and print for you. Easy हो गया. A variable where the p value is more than alpha, that variable will not be considered. Online students, clear for you? What is forward selection?
Clear, sir.
हाँ. पहले बीटा नॉट होगा. Second, it will take the variable which has smallest p value and it has to be less than alpha. इसमें smallest कौन सा है? Okay. If I do reverse order, okay. Let's say इसको मैंने x2 कर दिया, इसको x1 कर दिया, इसको x2. Which is the smallest one? तो first यहाँ पे क्या आएगा? x2. उसके बाद x1. ये हो गया. आ गए. So whichever variable have p value more than alpha, that variable will not come. 0.0. Clear guys? This is your forward selection. तो forward selection में variable add होते हैं. I'll give you theory to write also, don't worry today. Okay. First step, beta naught. Second step, first variable. Third step, second variable. We keep on adding until all variables have p-value less than alpha. Now backward selection. Now backward, what we do? We first run the model. Okay, and we get this as an output. Ye clear okay? This is step number 1. Can I say in step number 1, I have taken all the variable and run the model. Ye clear okay? Now what I will do, I'll find the variable which have p-value more than alpha and has to be highest. How many variables have p-value more than alpha? X3 and X4. Which is highest? Which variable? X2, X1 will be there and X4 will come. X3 removed. So let's say I'm just writing a random numbers, guys. Okay. Second, who is more than alpha? Which one? X4. So what remains? Here it removed. In forward we add. Got the difference? One is addition, one is removing. Both means apply both the combination. Whichever gives you the best accuracy, that will select it. That's the meaning of both. Any question on this, please ask. Conceptual clear, easy. Got the point, guys? Why I put in here as both. Because apply first forward, check accuracy. Apply backward, check accuracy. Whichever give you the best, select that. Both. It's work for both for you. It's your opinion. The data is small, both coming very faster. If a data is huge, see, doing forward 10 minutes, doing backward 10 minutes. And if you do both, how much minute? 20 minutes. When data is very huge. Okay, your data is small. Clear. Shall I move forward? Okay. Guys, this will give you error because this code I have not given you. It's a function. I'll give one drive to you later. Okay. Now we have all the variable and all variable p-values less than alpha. So that's the reason we say every variable is important. Now we need to check whether they are independent or not. So we run BIF. I say all the p-value is less than alpha. All the VIF value less than alpha. Sorry, I'm repeating. All the VIF value less than 10.
Yes, sir.
If VIF value is less than 10, it indicates there is no multicollinearity. Clear? Next. Next, we studied odd ratio, correct? Okay. When to use odd ratio? Anyone?
Comparison between two categorical variables.
The comparison between a category. So do we have category over here? Do we have category variable like gender or marital status? Or do we have numbers variable? So can we compute odds ratio? No. Got the point? In future, if you get category, you have to compute it. Okay. Currently, I'm just running the code. Okay. We cannot read, guys, because it's a number variable. We cannot read that. So rig model 1 is a model name. Okay. I want to do coefficient. This coefficient will give me all the beta values. On this beta value, I'm applying exponential. Will give you odds ratio. Now, guys, doing a prediction. Predict. What is the model name? Model 1. Data set name, training. Type is equal to response. If you write response, what happened? We get answer as probability. because binomial distribution give answer in terms of probability. Assigning in train, okay, making a new column called probability. Now, if you see, guys, in the train, how many rows, how many columns we have? 9. If I run this, how many it become now? 9 plus 1, 10. Do we have 10? You can see in my environment. Next, on screen. As I said, we get answer in terms of probability. Clear? How to read this probability, guys? Anyone? How to read this? 0.94. 94% chance that a customer will have diabetes. Okay. In the train, make a new column called predict. The prior, how many we have? 10. If I add 1, how many it's become? 11. If else, if the probability value is more than or equal to 0.7, the answer as 1, otherwise 0. Convert this 1, 0 into factor, means a category, and save in this. You see, we have now 0, 1. Okay. Now, guys, we need to make a confusion matrix. Okay. On screen. Library, same package. Function name, confusion matrix. Y variable is your outcome, actual data. We have predicted data. Positive 1 means your TP value has to be 1, because my objective is to find whether a patient have diabetes or not. This is my objective, to find 1. That's the reason I've written positive as 1. Yeah, how systematic it gives the answer. It gives you frequency table also. Plus, it's calculate accuracy for you. It also calculates sensitivity for you. Specificity for you. Systematic to read as compared to Python. So good or bad model, guys? When we say a model is good, what is the threshold? Above 70%. Above 70%, we say model is good. What is the accuracy we have? Good or bad? Good model. Clear, guys? Okay, I'll move forward to this one. Now, coming to predicting on test data. ROC code I skipped for you for a time name. Okay. What is the model name, guys? Right, model 1. What is the test data frame name? Testing. Why we write response? To get answer in terms of probability. The test data, how many columns we have? 9. I'm adding a new column called probability. Can you see? One column is added. Now, same way, the probability is more than 0.7, give answer as 1, otherwise 0. So we have actual outcome and we have predicted also. So again, we make confusion matrix. I'll repeat again. Make a confusion matrix. Y variable name is outcome. Predict as my Y hat prediction value. Positive as 1. How much is the accuracy, guys? On screen.
76%.
Good or bad?
It's good.
Sensitivity. Specificity. 74%. Okay. Now, guys, coming back to live data. Why we do this activity? Do we need this activity or not? If we need this activity, what is the scenario? Now, guys, as a machine learner model, okay, we make We works on train also, where we create model, correct? We apply this model on test data. We get the accuracy as 75% over here, and here as 76%. So we are happy. Can I say this is historical data, guys? In
Yes,
train
sir.
data, do we have X and Y both given? Correct? Then only we can check the accuracy, no? Agree? In the test data also, we will have X and Y. Applying model, what we do? We predict. Based on prediction, we get accuracy. So in the train and test, guys, we have historical data where we have X also and we have Y also. Then only we can check the accuracy. Now let's say we have one patient name, let's say I'll take as Shivam. Example. Say we have one patient. This patient has given all his information. What is the glucose level? What is the BMI? Okay. What is the thickness and so on. Okay. Let me show you. This is the data of Shivam. First data belongs to Shivam. First patient, second patient, third patient. Now guys, how we confirm a patient have diabetes or not? We go to doctors, doctor do some tests, and then they report whether you have a diabetes or whether you don't have. Clear? This is the process. Now for this data, without doctor, I have to predict. Because doctors charge you 1,000 rupees, 500 rupees, and you have to pay the money. Second, you have to go for test also. Again, cost to the patient. To reduce this, we came into the picture. Okay. So do we have Y variable over here? Where is Y? All X is available. Based on this X, I say predict. Using model, dataset name, library. Okay, type is equal to response will give me probability. Do we have probability now? Probability more than 0.7 give answer as 1, otherwise 0. Who is the highest chance of having a diabetes? 94% Shivam and third. The first patient and third patient have a high chance of diabetes. Now guys, my question for you on screen, okay? Can we check accuracy?
No, sir. Because
Why
we
not?
don't have any Y variable.
Because we do not have Y variable now. We just have done prediction for the live data. Now, when he go to doctor, when he do a test, and doctor say you have diabetes, that become Y. This we predicted. What is the chance he will have diabetes? Got the point, guys? Concept for live data clear? Any question, please ask. Guys, people will ask in an interview multiple times. So we make model so that we can predict for why we make a model. What is the use of model? Okay, we make so that future patient we can predict if doctor is not available, and we can start giving the medicines. There are some in general medicines every patient can eat. Like if for example 3 patients we have, out of 3 patients 2 have a diabetes. In diabetes we have diabetes type 1, type 2, type 3, type 4. We don't know which diabetes. So there are some company who make a medicine in general for all diabetes patients. At least a doctor come back, we can give him a medicine to make him stable. Got the point? Any question, guys, please ask. Concept clear? Online students, Shantanu, Kiran, Shubham, Yogesh. What is the concept of live data?
Clear, sir.
Guys, every time you have to predict for live data. because that is our job. That's the reason they hire us. Okay. Now when on screen we have ROC graph. Okay. What is the threshold we take as? Now 0.70, how it comes? Who tell you to take this one? It's given in the code you have written. But 0.7, how it decided? Can we know? It's a random deciding, assumption based. We can take 0.71 also, 0.769 also. We can take 0.8 also. How to decide this threshold? To decide the threshold, we use the curve name ROC curve. Okay, first include this. Okay. Now, guys, in the train data, do we have probability?
Yes.
In train data, do we have outcome variable as y?
Yes.
So what I do, I pick up this two column and make as prediction. From the model performance using a function from predicted one, TPR, FPR. Full form is what? TPR. What is the full form? T means true, P means positive, R means rate. So true, positive, rate. What is FPR? False, positive, rate. Perfect. Let me just make a plot. On screen, I'm just teaching you how to decide the threshold guys. This is the data we have, correct? Can you say this is one? What is the range of probability? Do we have 0 to 1? Do we have 0 to 1? Now, can I cut the page in half part? Can I cut the page in half part? Possible? Okay, let's say I'm cutting from here. Is clear? Okay. This is the line where they interact. At this point, in front of this, where it comes. ये clear हो गया? Approximate, I'm just writing approximate number as 0.76. So what should be the threshold? Got the point. How we decide the threshold? Any question, please ask. This dot, this black line, they are nothing but probability for each and every customers. नहीं, मैंने सिर्फ कट किया, डिसाइड नहीं करते। ये प्रोबेबिलिटी है। What is the first value? .002. It will come over here. Second point 004. थोड़ा सा up. This way we make a probability. Next, what we do? We just cut the plate. We sort data in the plot. ये clear हो गया? I just cut the plane. After cutting, I just cut from here. So the point of intersection is this one. The position which comes over here is 0.76. This way we decide our threshold. These are interview question, guys. How you decide a threshold? Okay, we use ROC curve. Point number 1. If not, we use business logic of 0.70. This is business logic based on experience. This is based on machine learning. Till you're clear? Any question, please ask. Easy here. Online students, easy for you? Okay. Same way, guys, will make ROC curve for test data also, just to check the both the data should follow same type of shape. Do we have the same shape? See, this is a testing one. See, they look like similar. Always. Second. Guys, any question for deciding threshold? No? Clear? Okay. Next, guys, you can see the pattern of train and test look like similar. Okay. The rules say, okay, the rules say data of this curve which you have drawn like this way, it should come close to 1. If the value is close to 1, we should have a best model. If it is coming like this way, your accuracy will be less than 70%. So if it's come close to 1 indication, yeah, model is best. Same way, can I say this pattern and this pattern, they are look like similar? Till you clear? Any question, please ask. Guys, I'm open to any question you have, can ask please. The phone is there. Is any question? Online students, any doubt you have?
No, sir.
It was easy. One second, let me share the new one. Okay, this will be the topic for your decision tree. Okay. So one example we done for logistic. Now we'll go for decision tree. After that, I'll give you data where you will solve logistic and decision tree for me. Okay. Start writing this one. Okay, I forget to upload. Guys, I'm just giving a data to you. Log into your drive. You can take data from your guys. Okay, Shantanu. Guys, take a break. After break, we'll continue. 10 to 15 minutes break, okay?
Okay, sir.
Online students, start attending this one. Online students, start attending this one. Guys, once you're done till line number 50, I'll explain the concept. Students, done for you? Hello. Guys, done for you?
Done, sir.
Okay.
Done. Till 59 done.
Okay. I'll explain the code on screen. So guys, here I have taken a data set, something known as employee data. Now, what is the meaning of iteration means when employee resign from one company and going to switch to another one. That resignation duration is called iteration time. Okay. So we have that data for us. Now, my question for you guys, when to use decision tree? Very simple question, when to use decision tree? To make prediction. Answer. Anyone? Guys, when to use decision tree?
If you have a supervised data,
Okay.
regression and classification, then
It's used for
that time we use
regression
this
and used for
and classification also.
when I say regression, what type of data we required? Which variable has to be continuous?
Our target variable is continuous and independent variable is continuous for category also.
Perfect. For classification, why should be category?
Target variable is category and
numbers of category. Why should be category with binary. It can be more than 2 level also, but for 2 level it works better. Okay. Now guys, in decision tree. Okay. What are the points? In Y? No. Either 1, 2, or either 2 or 3. Make sure. Then it will give a better answer. When you have multiple levels, the answer is not too accurate. Okay. Next point. Guys, in tree, what we do? What are the terms we have in tree? Root node, parent
node, and child node.
Terms. What is the difference between root node and parent node? Take entire data. Okay. What is parent node? Subdata. Child nodes? Homogeneous data. Perfect. Here we have homogeneous. Homogeneous means over there we have either yes or no. Here we have non-homogeneous data. Or we can also say subsets. From root node, we start a journey which have entire data. Okay, these are the terms. Okay. Now, guys, how many methods we have for splitting over here? 4. Which are 4? Chi-square, entropy, information gate. In your syllabus, guys, we have Gini, but I have given code for Gini and chi-square both. So we are using Gini. Okay. What Gini help us, guys? How it works?
To get data homogeneous.
To get data, but how it help us? So how we use Gini to make a tree? Explain me that.
Perfect split.
To find the perfect split, or we can say to find the best variable for split. Okay. So what Gini do? First, Gini compute for every x, he compute Gini value. Whichever is highest, that variable is selected. We keep on splitting and splitting until we reach homogeneous. Okay. If guys our tree get overfitted, what we do? Pruning. Overfitting means okay. So your accuracy will come close to 100%.
Close to 100.
In pruning, how many steps we have? Which are three? Maximum branches. Yeah, something parent. Number of sample in parent node. Same way, number of sample in child node.
Number of branches, number of sample in child node, number of sample in parent node.
So here we have 3 steps for pruning. We have splitting, we have terms, and this is the structure. Clear for everyone? Do you want me to teach you decision tree again? Shall we move to code?
No, sir. No, sir.
Okay. Now, guys, we have taken an employee data. Okay. Here we have y variable as attrition. Rest other variable are my x. Okay. Need to explain data, guys. We check structure of data. So here we have many variables coming as integer, float, character, and so on. What I do, I just have taken such their names. The total we have 35 columns. Okay. Out of 35, I remove irrelevant columns, which are column number 7. We have education and education field, both are same. Okay. We have employee count, employee ID, not relevant. So which are irrelevant column, I delete that. So 35 minus 5, how many remain, guys? 30. अपने multiple time रख दिया होगा. Okay. Now if you cross check, guys, we have only 30 columns. You can check in my environment also. We have 30. For every 30 column, guys, I just take the structure. Some are coming as integer. Some are coming as character. Okay. What I'm trying, I'm just converting this data into 2 separate parts. Okay. First, I have taken specific numbers column. Take a subset from employee and ignore column number 2, 3, 5. Except that whatever remain, give me. Now, if you see in employee 1, I write a flow chart for you guys. First, we selected employee data. Okay, which have 35 columns. we drop irrelevant columns. How many? 5. How many we have an employee? 30 columns. Now further I break data into numbers and category. Number columns I written the name as
employee 1.
Employee 1. Okay. If you can see in employee 1, all the numbers columns we have. You can see on the screen. Okay. This column coming as integer for me. I just converted all the columns to numeric. It is your convenience. If you don't know, it's fine. Okay. Second, I've taken employee 2, where all variables have character. So employee 2, all variables coming as. Be clear here. I converted. Okay. Next, I make this as data frame. And again, I check the structure. I have names. Again, we come back to 30. So we just converted this into numbers format. Again, we combine these two and we make something known as employee. Guys, over here, we don't require to do something known as, let's say, converting label and coder, not needed, because R accept category data. So you don't have to worry. Guys, your Y variable is nothing but iteration. What is the data type for iteration? Coming as character. So I'm just converting into factor format. Now can you see it's coming as factor? Clear. Important thing is your Y variable always has to be in factor. Next, any question till now? Next, guys, we do data partition. Need to explain this code. Okay. We split data into training and test with the ratio of 70 and 30. Now, guys, sometime in the interview, they ask you, when you split the data, your data is properly split or not? Do you know that? So we can say, we can verify that. Okay. Now understand the verification stage. In table, using table, employee data set, column name, iteration. How many rows and columns we have? How many yes or no we have? 37 no, yes. 1 to 3 is no. But same thing, if I do with training data and testing data, can you see frequency count are different because number of rows are separate? Okay. So we cannot compare the frequency. We will compare the ratio. So table will give you frequency converting into prop. Prop table means proportion. How much percent yes we have? Yes. 16%. The same ratio of entire data should reflect in training and test also. Reflecting. Then this indicates your train test split is proper. But the point, this is a verification for you. Yeah, auto work there, but you should be aware how we can give answer to the interview. We split data into train and test, but the ratio of Y in train should occur in train also, should occur in test also. If they are equal, that indicates my splitting is proper. Online students, any question, please ask. Guys, moving forward, we are using a package called RPart. RPart is to make the model of decision tree. RPart, attrition follows depends on dot. Dot means All columns, all data. Take data from training. Method is classification. This is the splitting ratio. Same we have, guys. Yes or no? If you round off 84 and 16, splitting method has to be in. Is clear? Okay. I just want to run the tree, guys. That's the reason I just make it smaller. Now, what is the model name? Model. I'm using R part 1. So R part is the latest package. Older also we have. Now inside that we have function R part plot. Okay, but the function which you have written is R part dot plot dot version 1. This function is older function. Older package, older function. Okay. If I go to the package for R part example, you can also cross check, guys. Do you have R part version 1 with you? R part plot. Do you have version 1? No. So you do not have this version. I have it because I have installed the older version. Okay. Also, I have latest version. The latest version function. R part plot. It's a package name, correct? Older function is R part dot plot dot version 1. New function is R dot plot. You can use this one. You can use this one. I prefer to use older one function, guys. Easy to read. I'll teach you how to install that also. Okay. I'm just running this. R plot version 1 function, make a model before pruning. This is the text size, okay, symbol size, and so on. Now, guys, if you see, can I say our tree is slightly used in size, but it is properly readable? Agree? If I say income more than 2,440, where should we go? This side. Person never do overtime. What is the answer? He will never leave the company. Means getting more pay and never do overtime. Employee will leave. But the point is how it works. Let's say I'll make a scenario for you. Let's say we have one student called, let's say Dheeraj. Dheeraj is single, get a salary of $3,000. Okay. He also on time. So where should we go? We should go first on this one. Income is less than, correct? He works as daily salary. If the monthly salary is 3,000, daily will be more than 300. Then he works as a sales representative. Example. What is the answer as? Yes. That's the point. So predict for Dheeraj as yes, he will leave the company. Clear. Now, guys, this tree is very huge in size. Okay, we can do pruning also. Before pruning, as we said, we need have to be overfitting. Correct? Overfitting means accuracy should come close to 100%. So let's make a tree and cross check. Okay. Model predict using model dataset name training type class Remember we type response. We write a type as a response. What response give us? Probability. Whenever we write class, it will give you 0 or 1. In the train data, how many we have in train data, guys? Number of columns? 30. Add a new column called. How many become now? Number of columns? 31. Make a confusion matrix of predicted versus actuals. Now you see the accuracy. What is accuracy, guys? Overfitting? No. Tree is not overfitting. Clear? So we can accept the tree. But if you can see, guys, the tree size is very huge. Can we reduce or not? Okay. So it is not only for overfitting. Overfitting, I have two definitions. One is accuracy. Second one is a tree size. Pruning से tree cut होगा. Tree cut होगा तो prediction में कमजोरी होगी. तो accuracy will decrease. Okay. So overfitting are two types. Either 100% accuracy or tree complexity, means tree size is very big. So do pruning can control overfitting by accuracy, can also reduce the size of the tree. I specify how many branches? 4 branches. Parent node, child nodes. Assigning in C. If you remember in training, we already added prediction. We don't want that column now. So we first remove that. Null is for delete. Again with tune. See, same code, R part. Iteration depends on dot, data, training, method, class. Okay. Control means how to control the overfitting. Then we make its plot. I am running again once again. See, it's easy to read now. Difficulties. We just have 4 split. Do we have 4 branches? First branch, second branch, third branch, fourth branch. Easy to read. Okay. What is the prior accuracy, guys? We have 88.5. So let me write for you. Okay. A big tree with accuracy. Now we make small tree with the help of. Now what I need to check? Accuracy. Again, same process. Predict in using tune fit model, new model, applying on train. Okay. And making training, we can adding a new column for predicted, and we make confusion matrix. What is accuracy now, guys? Around 27. How much % loss in accuracy, guys? A small loss make a tree small and easy to read. So this is also called as the best model. It should have around 27. Guys, any question, please ask. You want me to repeat any point? I'll repeat again. No issue for me. Till you're clear. Need to explain the code. Same thing again. Now we have applied the tune fit model on training. Same way we'll apply tune fit model on test data. Because once a model is ready, then we go for test data. Predict using tune fit. Model name, test data name, test. Class will give me 1, 0. In the testing, how many columns we have? 30 columns. I'm adding a new column called predicted. Do we have predicted now? Okay. Next, then we make a confusion matrix. What is accuracy? Close to similar, guys. Good model or bad model? Next, we check the accuracy, which find the variable which is most important. Which variable have the highest value, guys? Monthly, overtime. If I say top 3 variables, then these 3 variables. If I say, if a manager said top 5 variables, then you take this top 5. So this variable have highly influence on your model. Till you clear. Anybody have any question, please ask. If you practice 1 or 2 days for live data. In live data, guys, I have taken 3 customers data. One data is of Dheeraj, one is of Shubham, one is for Saurabh. The customer 1, 2, 3. Do we have over here Y variable for Saurabh with everyone? Do we have Y? No. So we just have their X data. We'll put this data as a model, predict, using new model name, TuneFit. Data set name, live data. Give answer in terms of class. So now if you see in the live data, first data is belongs to Dheeraj. Chances of living, no. Second belongs to Shubham. Chances of living, yes. Saurabh, no. But the point is, you are working, what company predicts for you when you will resign. So before your resignation, we're doing a prediction. When we come to know you are going to resign, we give you offer. Do not apply for resignation. It'll increase your salary. Any question, please ask. Guys, write this code so that you should not get any error. From line number 5 till line number 9. So that you should get older package. Our part for you. Write this code and run. And then delete the code. It's fine. Just write one time and run the code. Starting from line number 5 till line number 9. You write in console and then delete. This will help us to import older package. Guys, done with installation of whole package. Error I have. Then you can write this code. It will give you output. And I have already explained this code. You just have to write it. Write this one time training wala part till confusion matrix. Okay. And till here you have to write only one time. The rest other you just have to copy paste from the above. The code of R. Same code you have written on the top. It's faster, please. Guys, once you're done today, just inform me. Till line number 70. At least side till training data 92. Done for test also.
So test data prediction accuracy.
Your more, I think you may have an internet issue. Can you please repeat again?
Hello.
Yes, Kiran, I'm listening. Your volume is not clear. Can you repeat again?
So test data.
You have to write till over here, till live data. Okay. Kiran, till you have to, if you're done till test data, just write 2 more lines. You have to just write till live data. Just 10 more lines. Okay. This is the last one. So guys, till here, you will have a test on Friday. Linear logistic decision tree. Make sure you practice code.
And so basic R का नहीं है ना test अभी?
There will be 2 tests. First test will be basic of R. Second test.
एक ही दिन पर sir.
Yes.
Okay.
I'll write over your test
So
one.
क्योंकि first after Saturday we have ML2 का test भी है तो उसका भी पढ़ाई करना पड़ेगा.
ML2 test. You are learning the same thing, but the
हाँ,
coding.
which is हाँ. Okay.
I'm just writing a syllabus in the chat.
Okay.
Regression, logistic regression. Okay. Each test will be max to max half an hour, not too huge. So don't worry, okay? Okay. Guys, done till here? Guys, if we're done till here, we can stop. Okay.